So this is starting with number 23 on the Unit 4 test review. So we're talking about polynomials. The directions here are to factor, and there's two ways you can do it. I'm going to show you what I think is the most direct way. I'm going to show you that way first. Looking at an 8, a 36, and a 20, they have a GCF of 4 in common. So I'm going to take that 4 out. Remember to make sure you're dividing every term by 4. Doesn't go away, it's out front. Here's what I have left. Now, we have an A that's different than 1, which means this first number here is a number 2. It's not a 1. So this is where we say 2 and 5 is a 10. I'm going to ignore that 5 is negative right now. We get a 10. So that's 1 and 10, 2 and 5. This here says you want it to subtract. It's going to be different signs to get you a 9. So you definitely want the 1 and the 10. So you write 2w squared, 1w, 10w minus 5. So I've rewritten the first and the last term. 9w I split. 10 should be positive because it's the bigger number and 9 is positive. 1 should be negative. I get to that step. I'm going to do grouping. We look here. W is the GCF, 2w minus 1. 5 is the GCF, 2w minus 1. You put your GCFs together. W plus 5, 2w minus 1. Now, once you do that, you need to look and say GCF. You took out this GCF at the very beginning. That is part of your final answer. And you get 4 times w plus 5 times 2w minus 1. Now I'm going to show you the other way. Here's the first problem. Some of you will say 8 times 20. Well, 8 times 20 is 160. And you'll write out all the ways to get 160. 2 and 80. 4 and 40. Excuse me. 5 and 32. 6 does not go into it. 8 and 20. 9, no. 10 and 16. I think that's it. Anyways, the pairs that we need here. This means subtract to be 36. So we want a 40 and a 4. That's going to subtract to give us 36. We write it out. 8w squared. We have 4w, 40w minus 20. 36 is positive. So the bigger number is positive, smaller is negative. That would give us 4 terms. GCF is 4w. GCF here is 20. Oops, and it's positive, sorry. 2w minus 1. That's great. There's no problems yet. 4w plus 20. 2w minus 1. And then you think, oh, I'm done. You are not. This is done. There's no more factoring. 2w minus 1, done being factored. There's a GCF. You need to take it out. 4 times the quantity, w plus 5, times 2w minus 1. That's 2 ways to do number 23, and we get the same exact answer. So our order may be just a little different as far as what we do first, GCF in the beginning or at the end, but we get the same answer. Now let's move on to 24. 24 is 4 terms. 1, 2, 3, 4. So it's grouping. 5x is the GCF in the first group, and you're left with x minus 2y. Now, you may notice these are already the same. That's fine, but you got to go a step further. you have to say the GCF in the second group is a 1. It's prime. It can't have anything other than a 1 that goes into both of them. Then you say 5x plus 1, x minus 2y. Put the GCFs together, the groups were the same. Let's keep going. Let's look at 25 next. You may not know that 625 is a perfect square, but you should know that x to the 4th is x squared times x squared. So you're going to say x squared. 625, if you square root it in your calculator, you get a 25. 1 negative, 1 positive. And then you're like, done, move on. No, one more thing. This, with the plus sign, is not factorable. We cannot factor it. But if it has a negative, I can factor again because it's a perfect square and a perfect square. It's not just that there's a negative. It's that 25 is a perfect square and so is x to the second. We're going to break it down again. X minus 5, x plus 5, x squared plus 25. That's your final answer. So if you stop here at the second step, you're only about halfway through. You do need to keep going. 26. GCF. The GCF here is x squared. You get x minus 3 left. Second group. The GCF's a negative 4. Now, be careful. If that third term in the whole polynomial, the third term is negative, you're usually going to take it out. In this case, you are. So this is negative 4x divided by negative 4, and we have an x left over. 12 is positive. A positive 12 divided by a negative 4 is a negative 3. Then you put your GCFs together. X minus 3 is at the end. Once again, this is a problem where you're not done. This factors. How do I know it factors? Perfect square, and a minus. Those are your clues. X plus 2, x minus 2, x minus 3. So it's one step further, all because it's a perfect square. Now, if this 2 was not here, and that was just an x minus 4, you could not factor it again. It's because that 2 is still there and 4 is a perfect square. That has to come together, then it's factorable again.